So our first one was by maximums, because they're each gonna have their own, or minimums. The second one was by x-intercepts. Anybody remember another name we gave x-intercepts when we were talking about them in the quadratic functions? Starts with the last letter of the alphabet. Also known as zeros, remember that? And then by average, oh, I didn't make you write out everything, did I? Average rates of change over an interval. Just what we were doing yesterday when we had nonlinear functions. Over an interval. So all of these things we already know how to do. We're not learning anything new. What we're doing is just learning how to compare one quadratic model to another quadratic model. So in this particular one, they are talking about some passageways that are arch-shaped in the form of a parabola, and the models for two of these designs are shown at the right. Notice what they say. Models for two of them are shown at the right. One of them is shown as a what? Equation. Is there a picture to go with that equation? No, it's just the equation. And that's design what? Design A is given to us as an equation, and the other model is given to us as a graph, as a picture. So when that's design, and that's design B, thank you. Okay. So design A, we're going to write down that equation that they gave us. He said the model for it is y equals
Negative 2x squared plus 8x.
Okay. So it is quadratic. Y equals ax squared plus bx plus c. This should look familiar. What's the a value here? Negative 2. What's the b value? 8. What's the c value? 0. Would this, if there was a picture of this one, would it open up or would it open down?
No, down.
It would open down because what?
Negative.
Because a negative what?
A value.
Negative a value, because its a value is negative. So both of these actually open down, which makes sense, right? An archway, that is a passageway. So we have, we kind of have at least a little bit of a mental picture of it. And then for design B, we just said that's actually a graph, so any information we get from that one, we're going to have to get from the graph. Okay, so the first thing we're going to do is find and interpret the maximums. Why did I already decide we're going to find maximums?
Ouch. Because it's negative.
Okay, because it's negative. Well, that's
Because it's going to open down.
because it's going to open down, so the vertex is going to be at the top of it. So the y value of that vertex is going to be at the top of it, so it has to be a maximum. Okay, so the maximum is actually representing the highest point, right?
Yes.
Of that arch-shaped passageway. We're saying, oh, okay, it gets this high, and then the archway starts to come back down. So the maximum is representing the highest point, and it would be the, what did we say at the vertex? Which value, the x or the y? The y value, no, it's just the y value of the vertex is our maximum. So when we're looking for the highest point of this archway, we're looking for the y value of the vertex. So design A, we have to find the vertex algebraically. I wonder if we remember how to do that. Let's fill in what our equation is. It's y equals negative 2x squared plus 8x. And look at here. Remember this little formula? X equals negative b over 2a. Remember that? So do we even need the c value for this? No, we don't. So a is negative 2, b is 8. We already said that. So our negative sign that's in the formula is there always. And then we substitute in our b value, which is 8. And then we say 2 times our a value, and we substitute negative 2 in downstairs for that. And what are we actually finding here? Right now we're finding the x value of the vertex. It's the y value that we want, but we have to start by finding the x, okay? So this is gonna become -8 over -4,
Which is 2.
and that becomes +2, doesn't it? Because what we really have, maybe we'll just put one more little step here. We really have a negative, and that becomes a -2, that 8 over -4. And what's the opposite of -2?
2.
2. So the x value of our vertex is 2. So now we need to substitute that in for x in our equation, and we'll get our y value. This is stuff we did, it's been a while ago, but this is all stuff we've already done.
So we substituted into the x in our equation that we got first.
Yeah, so we start with that original equation. The one we don't have the picture of, this is the one we're doing right now. It takes more work because we don't have the picture. But trust me, I don't think you guys really want to graph it either, because for graphing it, you have to do a lot of work. So we're looking for the y value of the vertex, and we've got the x value to substitute in. And we follow our order of operations. Does -2 get multiplied times +2 first, and then we square?
No, you square first.
Yeah, we just do this part right now, so it's -2 times 4. We'd get a different answer if we didn't follow order of operations correctly. And 8 times 2 is 16. Okay, so we're gonna have y equals -8 plus 16. What is that?
8.
So the y value of our vertex is +8. Okay, 8 what? What do you think that is 8 what?
Feet.
Inches?
Feet.
Feet? Meters?
Feet.
Miles? Feet? Okay, so let's put that right behind you right now. We know that this archway is what? What does that tell us again?
8 feet.
It's 8 feet at its
That's
Top.
highest point, right? It goes up to 8 feet and no higher, and then it starts coming back down. So it's 8 feet tall. At its highest point, it's 8 feet. Okay, now we're gonna do design B. We got the picture. Go to your book and let's find the y value of the vertex. What's the highest y value on that graph?
9. 8. 9.
It's 9. And that's 9 what?
Feet.
Feet. So let's put that behind it also. So now we're going to compare. Remember, we're going to compare these 3 ways. First way is by their maximums or minimums. So we're ready to compare their maximums. What are we going to say about this design? We're comparing design A and design B. How do you want to state the comparison about something about their height?
Design B is higher than design
And its highest point.
So could we just say, let's kind of start like with how Matt said started. He said design B is higher than design A. And let's even be more specific. We only have one problem to do. We can do this. By how much?
A.
By 1 foot. Design B is higher than design A by 1 foot. So they want the highest one they can have, higher of the 2, they all go to design B. So that's for that reason, okay? Okay, so here we're comparing their maximums in this case, because both of them all go down. Okay. Any questions about that? Okay, then let's go to the back side now. I'm gonna guess the next one is the second bullet point. We're supposed to compare them by their x-intercepts. So find and interpret the x-intercepts. The difference between the x-intercepts, okay, let's stop and process here for a moment. I want you to think about these archways. So here we have these archways that are upside down U's. And the x-intercepts are where they cross the x-axis, which would probably be what in the real world? The x-axis would represent the ground. So when this archway comes down to the ground, It's asking us right here, the difference between the x-intercepts represents the what? No.
Wait.
The difference between, so from here, this x, let's
The
say
width.
how, right here,
It
and
is.
The width.
how wide it is, yeah, the width of the passageway. So when we find this, we're gonna say, oh, I'm really gonna be comparing their widths. Which one opens wider? So design A. Find the zeros of the function. Anybody remember how to do that?
I don't think I know how to do that when we were doing that.
Oh,
so-
yes, you did. It's when y is equal to 0.
Oh, just kidding.
Remember that? So, in other words, we put 0 in for y, and we have all kinds of methods. We have the GCF method, we have the factoring by the diamond method, we have the factoring by grouping method, we have the quadratic formula, we had all kinds of ways we learned how to do this.
Did we do the rectangle thing?
FOIL is multiplying back out.
Oh. That's
multiplying. You guys think you multiply. We're gonna undo multiplication, is what we're gonna do. So, and remember, I taught you all these ways, and then we brought them all together, and we said, what's the first thing we're always going to check for?
Zero.
GCF. That's what we said. We're always gonna check to see if we can GCF it. So, first of all, let's write down our equation. Remember, design A we're working with. And what we do is we put 0 in for y, but basically what we're gonna do is we're just gonna take this part right here, the negative, since it's set equal to y, we can take what it is equal to and we can start factoring this, use the quadratic formula, whatever it is we wanna do. We're gonna see if we can GCF it. Can we GCF that?
Yeah.
Yeah.
Okay, what divides out of both terms?
Two.
A 2, okay, what else?
One.
X.
An x. And remember, what did I say? We always, whenever we divide out, we always want to make it a positive if we can. So can we divide out a negative 2?
Yeah.
Could we divide 8 by negative 2?
4.
Yeah. And x squared and x both can be divided by x. So wouldn't our GCF, couldn't we go with a negative 2x as our GCF? Well, after we GCF it, okay, let's just set this equal to 0 over here. After we GCF it, in other words, we divide out a negative 2x. What's negative 2x squared divided by negative 2x? No. What's negative 2
One.
divided by negative 2? 1. But what's x squared divided by x?
X.
X.
1x.
So wouldn't it be a 1x?
X.
Yeah.
Yeah, it'd just be x. Oh, we have rusty memories, huh? What's negative 8, or 8 divided by negative 2?
Negative 4.
Negative 4. What's x divided by x?
Cancel out.
They cancel out, they'd be 1, right? Negative 4 times 1 is? Okay, so 8x divided by negative 2x is negative 4. Remember this?
Yeah.
Yeah. Okay, now we see if we can remember what we do with those factors. What do we do with those factors now?
Oh,
Don't we
yeah.
take negative 2x and multiply that by x, and then do the same thing?
No, you go.
Then we'll just take it back to what we started with, right?
Oh,
You could do that to check to see if we factored it right.
you go
Okay, so I
4
got
plus-
somewhere.
You go negative 4 plus x, then you take that times negative
That's what Brian wants to do too, and then that'll just take us right back to where we started.
FOIL method?
Because why do we want to multiply it back out? We just unmultiplied it. Why do you want to
2.
multiply it again?
Negative x squared.
Should we just keep going back and forth?
No.
I don't know.
I give up. I'm out.
Okay, let's go back to when we did the diamond method, and maybe one of our factors was x plus 3 and the other factor was x minus 4. What did we do with those two factors?
Only the diamond.
Really, but
Set them,
Equal to 0.
there you go. So we're gonna take each of these factors and we're going to set them equal to 0. So negative 2x gets set equal to 0, and the x plus negative 4 gets set equal to 0.
Oh, I remember.
Oh, now is this coming back?
Yeah.
oh
Okay, we gotta get this one solved for 0 first. Negative 2x equals 0. What do we do to both sides?
yeah. So negative 2.
Divide by negative 2. So x equals
0.
0. Okay.
And then
Over here, what do we do?
Add
Add 4. Okay. So x equals 4. So So we just found the two places it's gonna come down to the ground, right? If we had a number line down on the ground, we would say, oh, the x-intercepts are at 0 and 4, so how wide is this archway?
4 feet.
4 feet wide. Oh, I love the graph, because all we gotta do is look at the picture here.
0 and
6.
0 and 6.
5.999.
It's 6.
So, in our next one, design B, 0 and 6. Right, does everybody agree? Look at the picture and make sure that you agree.
Yes.
Is it touching the x-axis at those two numbers, 0 and 6? So how wide is this passage?
6 feet.
6 feet wide. Okay, so we gotta make an interpretation here. What are we gonna say?
Design A is 4 feet, and design B is 6 feet, therefore is a 2 foot difference.
Okay, so design A is 4 feet wide,
Is it okay if I just say design B is bigger than design A by
not bigger, but wider, we're gonna use a better word than bigger. Design A is 4 feet wide, I'm gonna continue with Cassidy's here, and design B is 6 feet wide. Then we're gonna say that design B is,
Why?
and since we already gave the numbers in here, we can leave out exactly how much. We're gonna say design B is wider. Or you could have stated it, design B is wider than design A by how much? 2 feet. That'd be another way we could say it. 4.
Wide and.
Okay, so questions about the interpreting the x-intercepts? Okay, and the third and final thing we have to do is find the average rates of change. And in this one, it said over the interval 0, 2, okay? So over the interval 0, 2. So for design A, I say substitute 0 in for x and 2 in for x into the equation. Because what do we need? What are we trying to find when we do that? We don't have a graph, remember, so if we want to find a rate of change, it has to be between 2 points, doesn't it? So do we know the y values that go with those x values? Without a graph? Anybody happen to just know the y values that go with x equals 0 and x equals 2? No. No, so we're going to find y. And so why don't you add that here? We need to find y, that's why we're doing it. That's our reasoning. We need, for our slope formula, we need some y's, we can't just have x's. So we're gonna substitute in, well, you know what, no, maybe we didn't, not yet. Okay, so there's that one. And then this one, we're gonna have y equals negative 2 times, yeah, this one we did, didn't we, already? Feel like? Maybe not. Okay, so we have negative 2 times 0 plus 0. That's 0. Y equals 0. So I'm just gonna go put it in my little table I started over here just so I can see what it is I'm actually doing. We're finding a couple of the points that would be on this quadratic function, this parabola. So even though we don't have, remember, we know it opens upside down, but we don't have any of the points from it, do we? Except the vertex, we did find that earlier. Okay, and then, this is the one I feel like we've already done, you guys.
Yeah, we did.
Yeah, when we did the vertex, right? This is the vertex, isn't it?
So do we have to do this again?
Well, I guess you could just state what it is, because we already know it. It's 2h, right? Now, over the interval that they do, it won't always be the vertex, so be careful. Just be careful about that. That's why we just did it, because I don't want you to assume they're always going to have you do it with the vertex included. what they're actually having us find then, you guys, is, we are finding, let me do this first here. We are finding, first of all, when x is equal to 0, that would be this point. When x is equal to 2, that would be this point, because we said it's the vertex. So what we're finding is the slope of that line segment that would connect those 2 points. So that's what we're gonna do next. We're gonna find that slope. Okay, so let's take our ordered pairs and let's substitute into our formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1.
Zero.
So we get
Minus
M
zero.
equals, we'll let that be the second point. 8 take away 0, the y's are upstairs. 2 take away 0 is downstairs. So we end up with 8 over 2, which, where's my, can't move over any. So M equals 4, and that would be for what?
4 feet.
4 feet per, do we know? What's that representing?
Foot up per foot side.
We don't have a graph, do we, to help us be able to say what the x's and the y's are representing? No, we don't, we know the y's are representing what? Feet. So we'll just leave it at that, the slope of this one is 4, okay, we won't give it a label. And then design B, get the order of pairs from the graph. So you have to use though when x is equal to 0 and x is equal to 2. So go to the graph, what are the y values? So Garcia, what's the y value for when x is equal to 2? I'm gonna randomly start with that one. Look at your book, look at the graph. What's the y value when x is equal to 2? 8? You all agree with Garcia?
Yeah.
Okay. What's the y value class when x is equal to 0? 0. You all agree? Okay. So now, what do we have to do? Same thing we did over here. M equals
0 subtract, or 8 subtract 0.
8
over
subtract
2
0, the
subtract
y's, and 2 subtract 0, and that equals 8 over 2, so M equals
4.
4. So what's happening here? Over the interval from 0 to 2, what's happening? It's rising at the same rate. So it's, both designs are rising, I didn't give this much room here, rising at the same rate over the interval and notice how we do the notation for it. It's not parentheses, that would look like an ordered pair then. Over the interval 0, 2. Okay. How do we know it's rising? When it's positive, yeah, right? Okay, with the rising part, and not the falling part. Okay, so that's what you're doing in that one problem of homework.